Structure of an atom. Now what this basically means is that when we talk about an atom, okay, let's say for example, this larger box represents a single atom. What I mean by structure of an atom is not about the shape of an atom. What I mean is what is included within an atom. When I say included, obviously it has to be within the atom. So there are basically, if we talk about it, there are three kinds of things, okay, which are available in an atom. And let me make different boxes for them with different colors. Now, the three things which are available in an atom are the electrons, the protons, and the neutrons. Right? Just like in a normal life, if you do mathematics, you would understand that +5 when added to -5 gives you 0. Right? 0 is neither positive nor negative. You must be wondering, why am I giving you this example? This is something similar to what happens in an atom also. So in an atom, the positive Now in an atom, the positive charge, okay, so each of these constituents are either positively charged, okay, or these are negatively charged, or these are not charged, or they are neutral. Depending on these qualities, just like you have +5 positive, the ones which are positive are the protons, okay, the ones which are negative are the electrons. Of course, for positivity you have P for proton. For the neutral ones you have neutrons. These are neither positive nor negative. So protons are the positive ones. These are charged positively, right? Electrons are the ones with a negative charge. And neutrons are not charged at all. To maintain the balance of an atom within itself, okay, it is essential that the number of electrons, okay, let's say for example, if there are 5 electrons in an atom, the number of negatively charged particles called the electrons is equal to the number of positively charged particles or the protons. So in such a matter, what happens is that the positives and the negatives in the form of protons and electrons are equal. Neutrons basically do not make a difference, right? So basically what this does is that this basically balances the charge in an atom. Right? But what can also happen is that through chemical process, what you can do is you can remove or add, okay, remove or add an electron to the atom. So let's say for example, if you have 5 electrons, okay, and you remove one, how many electrons are left? We are left with 4 electrons. How many protons are there? There are 5 protons. Please note that the removal or addition can happen only for the electrons. Protons cannot be removed, right? So if you remove, the situation we left out is 5 protons and 4 electrons, right? So the negatives are 4, the positives are 5. Which one is more? Obviously the positives. So we say that the electron is positively charged, right? Whereas if contrary to this, what I would have done is that we had 5 electrons and 5 protons. If I added 1 electron to this, I would get 6 electrons and 5 protons. So these 5 protons are going to negate the negative energy generated by 5 electrons, but 1 will still be left. So we will have 1 negative electron which will be in excess. So we say that the atom is negatively charged. Again, as I said, one of the things that you need to note here is that the addition or the subtraction for that matter can be only for an electron. It cannot be for a proton or a neutron, right? Ions, as we call them, is nothing but either a positively charged or a negatively charged atom, or maybe even a group of atoms. We're going to learn more about ions in the next video, but this is how the structure of an atom remains. It has electrons, it has protons, and it has neutrons. Of course, the placement of these three is also important within the atom, but that is not something which we are discussing out here. So I hope you would have understood about the structure of the atoms and ions. On the ions, we are going to take a separate video where we'll be discussing them in more detail. Thank you for being with us today.